Hi everybody. One of your lessons this week is lesson 6, and lesson 6 explores how to find the total volume of two rectangular prisms that are non-overlapping but are stacked on top of each other. So multiplication is what we're going to use to find the volume of these prisms. It's best to start by looking at the prism that has the length, the width, and the height labeled, because that kind of helps you understand how to find the length and the width and the height of the second prism. So I'm going to use some colors to help us with this. So I'm going to label this bottom prism for problem 1A. This is going to be prism A. And then the top one's going to be prism B. So again, if we're finding the total volume, then the total volume is going to end up being prism A plus prism B. That's going to be our total volume. So the first thing I'm going to do is I notice in prism A that my length is 14 centimeters. I see that my width is 3 centimeters. And that my height is 5 centimeters. And so one of the ways we've learned to solve this is to find the volume. We can do length times width times height, and that would give me the volume of prism A. So I'm going to do this. Prism A equals 14 centimeters times 3 centimeters times 5 centimeters. And then I'm going to solve. So I have 14 times 3. I'm going to do that. Actually, I'm going to do it off to the side here. Fourteen times 3. 3 times 4 is 12. Here's my 1. Okay, so we have 42. And then we're going to have 42 times 5. 5 times 2 is 10. 5 times 4 is 20 plus 1. So we have 210 centimeters cubed. So this is the volume of prism A. Now, when solving a problem like this, I want you to think about that prism on top. And what do you notice about prism A and prism B? So, first off, I notice that the length of prism A and prism B is the same. I notice that the width is the same. Even though the width and the length are not labeled as 14 centimeters and 3 centimeters, I see that prism B sits directly on top of prism A, which means that these side lengths are going to be the same. And then I also see that the height of prism B is also 5 centimeters. So to find the volume of prism B, I could again do 14 centimeters times 3 centimeters times 5 centimeters. But since I just did that work and I see that prism B is exactly the same as prism A, I know that this is also going to be 210 centimeters cubed. So to find my total volume, I can add those two together. So we have 210 plus 210, and that's going to give us 420. So my total volume is 420 centimeters cubed. Now, down here at the bottom, it wants a solution strategy. So what was our strategy for solving this problem? So if I was going to write out my strategy, I might say, I found volume of the bottom prism by multiplying length times width times height. The top is the same. So I added both volumes together. So that was our strategy. That's what we did. Those were our steps. I found the volume of the bottom prism by multiplying length times width times height. The top is the same, so I added both volumes together. And that's how we would solve problem A. Now, moving on to problem B, you should notice that we no longer are working with two prisms that are the same size. So we're still going to use some of the same strategy as far as we're going to start with the prism that we know the most information. And so if we're looking at problem B, I can see that this bottom prism, which again, I'm just going to label as A and B, I can see that in prism A, I've been given the length, the width, and the height. And so I'm going to use that understanding. Volume equals 15 inches times 4 inches times 6 inches. And so then I need to do my multiplication there. And so depending where you're at in your multiplication skills, you might multiply 4 and 6 together and multiply that by 15. You might like to do single digit multiplication. So you might do 15 times 4 first and then multiply by 6, which is what I'm going to do over here on the side of my paper. So I'm going to start. So I'm just going to put A so I know that that's A. I'm going to start by doing 15 times 4. 4 times 5 is 20. 4 plus 2 is 60. And then I'm going to multiply 60 by 6. 0, 36. Okay, so I know that the volume of prism A is 360 inches cubed. Now notice I'm paying attention to my units. It's going to be different for each problem. So unlike problem A, prism B is not the same size, but I can still use some of the information. So when I start to look at that, I want to identify things that I know, okay? So I can see that prism B sits directly on top of prism A. And I can see that the width of prism B is the same size, has the same side length as prism A. So the width of prism B is going to be 4 inches. And then I see, okay, they are telling me that the length of prism B is 7, and that the height is 3. So I can solve that. So we have volume for B, which is going to be 7 inches times 4 inches times 3 inches. Length times width times height. And I'm going to solve that up here. Okay, so I'm going to do this in my head. 7 times 4 is 28. And then we're going to multiply that by 3. So 3 times 8 is 24. 3 times 2 is 6. Plus 2 is 8. So we know that volume of prism B is 84 inches cubed. Okay, and what did I say we need to do in order to find our total volume? That's right, we need to add our volumes together. 360 inches plus 84. Make sure you line those up. So 4 plus 0 is 4. 8 plus 6 is 14. Carry my 1. 4. So my total volume, 444 inches cubed. Now for your solution strategy, again, you're going to walk the person looking at your work. You would walk them through how you solve this. So I might switch it up. I multiplied length times width times height to find the volume of the bottom prism. I noticed that the width of the top was the same. So I multiplied. Now I could say times, but multiplied is more academic. So I multiplied length times width times height. And now I'm really going to shorten. And then added both volumes. There we go. Okay, so I multiplied length times width times height to find the volume of the bottom prism. I noticed that the width of the top was the same, so I multiplied length times width times height and then added both volumes. Okay, so moving on, we're going to do the last two. I wanted to walk you through some practice before you did your Zern lesson, or if you've already done Zern but you struggled a little bit in lesson 6, then you can come back and watch this video. Of course, at any time, if you feel good after watching A and B, you can stop the video. But if you'd like to see A, B, C, and D, then stick with me. Okay, so again, in problem C, we have 2 prisms. We see that they are of different sizes. Okay, so we're going to start with prism A, or structure A, I should probably be saying. Okay, so in structure A, what do we know? We can see we're given the length, the width, and the height. Okay, this one's pretty clear cut. So I'm going to do VA equals 10 centimeters times 3 centimeters times 2 centimeters. Okay, and I'm going to do this math in my head because I see that this problem contains a 10, which makes that much easier to multiply. So I'm going to do this a couple ways. I could do 10 times 3 is 30. 30 times 2 is 60. I could also do 3 times 2 is 6. 6 times 10 is 60. So this is 60 centimeters cubed. Okay, now problem C, we are still given some information, but it's given to us in a little bit different format. It's going to cause us to be problem solvers, okay? So to do some additional math in order to find side lengths. So when I'm looking at this, I can see that they have given us the length of this portion of the bottom of structure A. They've said that from here to here, this is 6 centimeters. Okay. And I can see that structure B is sitting directly on top of structure A. So I know that if I look at structure A, this part that I'm highlighting in pink, this part of length side of structure B and this length side they've given us of structure A, if I combined those two, that's going to equal 10 centimeters. So I have to think to myself, okay, so if this is 6 and I don't know what this is, but I know that all together it equals 10, what would this be? And so I think about what I know either about addition or subtraction. 6 plus what number gives you 10? Well, I know that 6 plus 4 gives you 10. So I know that the length size of structure B is 4 centimeters. Now, kind of with that same thinking, structure B sits directly on top of structure A. So my width size is going to stay the same at 3 centimeters. And then I can see that they have given us the height of structure B. So the height of structure B is 4 centimeters. So I have volume B, which is going to be length, 4 centimeters, times width, 3 centimeters, times height, 4 centimeters. And so when I do this, I have 4 times 3 is 12. 12 times 4 is 48. I'm going to write it like this, 48 centimeters. So cubed. So now I have my two volumes, which I can add together. I'm just going to do that over here. 60 plus 48, 8, 10. So our total volume is 108 centimeters cubed. And then for your solution strategy, again, you would walk us through what steps did you use to solve. Okay, so looking at problem D, again, looking at two structures. This time they've added some arrows. And those arrows are really just to help you clarify side lengths. So I'm going to label A. Labeling just helps me keep things organized. And they really didn't give me a lot of room in here. So I'm actually going to use this space in my solution strategy to solve. So here's what I can see. I'm going to start with length. The length of structure A, 10 meters. Width, 3 meters. Height, 6 meters. Okay, pretty straightforward. So volume of A equals 10 meters times 3 meters times 6 meters. And I want you guys to take note, when I am writing out my length times width times height, I am making sure to include those units. When you work in volume, you must include your units when you're writing out your side lengths. Okay, so I'm going to solve this. I can see 3 times 6 is 18. 18 times 10 is 180. So the volume of structure A is 180 meters cubed. Okay, so now I'm going to approach structure B. And again, they've given us some information, like they've showed us that the length of structure B is 8 meters. Okay, so we know that, but we still need to figure out the width. I can see that structure B sits directly on top of structure A. So my width is going to be the same at 3 meters. And then when I look at the height is right here. Now, these two structures, based on perspective, might not look like they're the exact same height, okay? And so we can figure that out. I know that on structure A, the height was 6, and I can see that the height of both A and B together is 12. So I can use those math skills that I have. 12, okay, minus 6 for structure B is going to leave 6 meters. Okay, so I know that the height of structure B is 6 meters. So volume of structure B, length, 8 meters, times width, 3 meters, times height, 6 meters. And so then I can go ahead and solve this. So 8 times 3 is 24. 24 times 6 I don't have off the top of my head, so I'm going to do that right here. 24 times 6. 6 times 4 is 24. 6 times 2 is 12, plus 2 is 14. Okay, so the volume of prism B is 144 meters cubed. I'm going to add my volumes together. 144 plus 180, 4, 12, 3. So my total volume, 324 meters cubed. Okay, guys, so this is just some additional practice in lesson 6. If Zern was not as clear as you needed it to be, you can always send me a message to ask questions around lesson 6 or around any of our lessons this week. I'm more than happy to help. I think seeing the problem set sometimes can also clarify some of those concepts that you are learning. So I hope you watch this video, and I hope it helps you. Thanks.